A disaster rewrote the story of life on Earth, and fresh fossils from Tanzania and Zambia are finally revealing how it happened. But here's where it gets controversial. Our long-standing picture of this crisis may be too South Africa-centric, and these new finds challenge what we thought we knew. Paleontologists have pieced together a crowded cast of characters that flourished in southern Pangea right before the End-Permian mass extinction 252 million years ago. Saber-toothed hunters, tunnel-digging plant-eaters, and even a hulking amphibian that looked like an oversized salamander. Imagine an evening scene in the late Permian Luangwa Basin, now eastern Zambia. Gorgonopsians with scimitar-like canine teeth, stalking among herds of beaked dicynodonts. It sounds cinematic, and yet it's grounded in new evidence. The End-Permian mass extinction was nothing short of a cataclysm for life on Earth, and changed the course of evolution, said Professor Christian Sador of the University of Washington. And this is the part most people miss. Despite its importance, we still lack a full accounting of who made it through, who vanished, and why. The Tanzania-Zambia discoveries promise a broader, more global window into that pivotal turning point. The new fossils come from three rich basins across southern Africa: the Ruhuhu Basin in southern Tanzania, the Luangwa Basin in eastern Zambia, and the Mid-Zambezi Basin in southern Zambia. Many were uncovered during multiple month-long expeditions over the past 17 years. Others were hidden in plain sight. Museum specimens collected decades ago and now reanalyzed with modern techniques. According to Sador, these regions preserve exceptionally well-crafted snapshots of Permian life on land, offering detail that is both rare and revealing. To understand why this matters, zoom out to the bigger picture. The Permian capped the Paleozoic Era, a time when life that had first evolved in the oceans firmly established itself on land, building complex ecosystems across forests, floodplains, and dry valleys. By late Permian times, the continents were welded into Pangea, and diverse amphibian and reptile lineage animals roamed these landscapes. Then came the End-Permian mass extinction, the most severe biological crisis in Earth's history, which annihilated many ecosystems and cleared the stage for the Mesozoic Era, the age that would see dinosaurs, the first birds, flowering plants, and eventually mammals rise. For decades, scientists leaned heavily on the Karoo Basin in South Africa to reconstruct this saga. The Karoo's rock layers provide an almost continuous fossil record straddling the extinction boundary, making it a global reference point. But here's where interpretations start to diverge. Since the 1930s, researchers have known that Tanzania and Zambia hold fossil records nearly as pristine as the Karoo. If multiple regions record the same interval with fine detail, are we seeing a global pattern or regional quirks? The new expeditions represent the most comprehensive analysis so far of pre- and post-extinction life from these Tanzanian and Zambian basins. The number of specimens we found in Zambia and Tanzania is so high and their preservation so exquisite that we can compare species one-to-one with what's known from South Africa, Sador said. I know of no better places for getting the level of detail needed to draw such precise comparisons. That means scientists can now test whether trends seen in the Karoo, such as which herbivores dominated or which predators disappeared first, truly reflect global events. In a series of 14 papers in the Journal of Vertebrate Paleontology, the team describes several newly identified species, especially among the dicynodonts. These were small burrow-adapted herbivorous synapsids, relatives of mammals, that first appeared in the mid-Permian. Picture sturdy bodies, a beak-like snout, and often a pair of modest tusks that may have helped with digging or defense. By the brink of the mass extinction, dicynodonts had become the dominant plant eaters on land, shaping ecosystems much like deer or antelope do today. The discoveries don't stop there. Researchers also report multiple new gorgonopsians, large saber-toothed predators that likely sat near the top of the food chain, as well as a new temnospondyle, a bulky amphibian reminiscent of an enlarged salamander. Together, these finds flesh out food webs right before the crash, giving clues about predator-prey balances, habitat use, and resilience. Crucially, Comparing these Tanzanian and Zambian assemblages with those from South Africa allows scientists to ask sharper questions. Were survival patterns consistent across Pangea, or did local environments dictate winners and losers? Did burrowing lifestyles or generalist diets provide an edge? And this is where debates heat up. Some researchers argue that the extinction was a rapid near-instant shock. Others see multiple pulses or region-specific timelines. These new fossils could tip the scales by revealing whether ecosystem collapse played out in sync or in staggered waves. We can now put two different parts of Pangea side by side and track what happened before and after the End-Permian event, Sidor said. That lets us truly probe who survived and who didn't. For beginners, think of it like comparing two high-definition replay angles of the same game-changing play. If both angles show the same sequence, you're confident in the call. If they differ, you look deeper to understand why. Bold takeaway. A broader fossil record from Tanzania and Zambia is challenging the idea that the Karoo alone tells the full story. Does this mean some classic narratives about the End-Permian crisis need revision? Should we expect to find different survival strategies working in different regions? What do you think? Is the extinction best explained by a single global catastrophe? Or by a complex patchwork of local collapses and rebounds? Agree or disagree, share your take. And if you have a favorite culprit, volcanism, climate warming, ocean anoxia, make your case in the comments.